Mhm. Hello, can you hear me, Deepka?
Yes, sir.
I think we should wait or we should start.
We can wait.
Last class you came, right?
Yes.
So you were giving all the answer, right?
Yes.
Mm. Hopefully one person came again.
Mm.
I don't know. This is a little bit difficult also, not that much easy. So you are doing a master or BTech?
Masters, final year.
Which institute?
MS University, Baroda.
Okay, Baroda, Gujarat.
Yes.
So you are from civil or mechanical?
Civil. Civil and then structural engineering, that sub branch. So we have the dissertation topic of FEM. So it is
Mm.
useful for us.
So structural we are having FEM. Without FEM we cannot solve anything in structure.
Mhm. Yes. We had one subject in first year, FEM, finite
Mm.
element method. We have basic knowledge. Like last lecture, you were discussing matrices. This, so we are studying in BTech only. That
Ah,
A plus B into BS.
but even though sometime we forgot, even we long time in BTech, like we
Yes.
forgot how to add. So that's why I just went a little bit fast. And when we are like slowly, this will pace up because the quality of question, quality of content will increase. So
Yes.
it will start going away from our mind.
Yes.
FEM like this only. I went 2, 3 times, then I got some idea. Yeah, this is FEM.
Mm.
Okay, then how we will going to start? Only one. Okay, I will teach you.
First, start with that summary if possible. Then it will be easy.
So last class
Last
summary, right?
lecture, first week lectures, I have mostly two or three I have completed. So that we were not getting idea, then I am getting that. I have screenshots, I have that questions. So I was able to solve that.
So whatever important, I will go through a little bit summary. Then we will start. Okay.
Yes.
Then okay.
One session also was there of FEM in between. Like today is Friday, Tuesday, Wednesday also it was there. But that
Yeah.
I didn't win. I don't know that.
That we are having two TA
Okay.
in this course. So he is also teaching same, but both are
Hmm.
having different method to teach.
Yes. You are covering all, na? It is not that we need to watch all, Friday, Tuesday, both. It is
No,
okay
no,
if we
no.
watch only Friday.
Yeah, like any of one you can watch. Or if you
Yes.
are having time, you can. I don't think everyone having this much time to watch 2, 3 times, 2, 3 lecture.
Yes.
So if you wish, you can watch, but mostly we are going to cover same. Just like this interaction session, just to like if you are having any problem, then
Hmm.
you can discuss with us. Or if you are having a specific problem, then we will forward to Professor Sir.
Yes.
So that's why they arrange this TA to T.
Hmm.
And so like this is a real content that we are going to. You have the all slide, right?
Yes. It's okay.
You can download from that website.
Yes.
So this is a real that FEM that we are going to start from this class, that FEM 01.
Yes.
Like how we are going to model the structure, how we are going to calculate stiffness matrix,
Hmm.
then more different type of method. Slowly we will go then, and then coming to this weighted residual method. So these are like whatever we discussed last class, na there's a 2.2, 3.2 rule that we are going to use here.
Yes.
We'll open PDF. This uh, like this integration we cannot solve
Yes.
by like our normal method. So we have to use that 2 point, sometimes 3 point. So I will go through one question, then it will be clear for you that 2 or 3 Gauss coordinate method.
Hmm.
So I will give you one question, then you have to solve. Okay.
Yes. It is better initially if you one solve, then I will solve next.
Okay.
Similar
Fine.
or
Okay. Okay. So I will solve one question, then I will give you one, then you will
yes,
can solve that.
yes. Mm.
So like no, we discussed like what the like W1 value, X1 value. So for okay, I will open in this one also in PDF. Like first week class not that much important because these are the basics, so anyone can learn. Now start from second week, it will be little bit like in-depth FEM.
Yes.
So this point. So I will go through a little bit summary. Like as we discussed like X1 and W1,
Mm.
X2, W2. So these will be our point. Like if I'm saying 2 point Gauss legendary quadrature rule, it will be like this. So it will be X1 will be 1 by root 3, then X2 will be
Mm.
minus 1 by root 3, then W1 will be W1 and W2
One.
will equal to 1. So
Mm.
like up to 5 point they like given that these rules 1, 2, 3, 4, 5. So for example, if I'm saying you have to use that 4 point that Gauss legendary quadrature rule by you have to solve an integration. So what you will do, you will say x1 will be this much, then x2 will be minus k minus,
Yes.
then again, and this w1 w2 will be same, and w2
Yes.
w2 w3 will be same.
Mm.
So similarly for 5 point, but normally we are going only till third 3 point rule. We are not going for
Yes.
4 and 5 because it will be a little bit complex. But for like when we are writing any MATLAB code, any Python code, we can go for any 4, 5 or more than 5 also. But
Yes.
when we are doing in our, by our hand analytically, then we have to go through only 3 or 2
Mm.
or 3, 2, 1. So then okay, I will give you one for example. So this is a general rule.
Yes.
Like it can be like for example, we want to calculate some volume. So what we are doing, or we are doing some double integration or triple integration. Then by using it will be for it I will be for W1,
Mm.
J will be for W2, like that, and we are having function of X. So
Mm.
this type of problem will be going to ask in your that your that what we are that weekly quiz assignment,
Yes.
a question and same in your exam as well, that final exam. So this type
Yes.
question going to come. So
Mm.
then okay, we will solve one question. Mhm. First, like integration I equal to. So the last time I discussed like how to change that limit, right? You
Yes.
remember
Yes.
that one?
Minus 1 to 1, and you told.
You remember, right?
Mm.
Okay, so just try this question.
Mm. ZXY.
So this is a last year question, like in some that USM FEM subject. So a heap of grains dumped on the level, like something they throw it on level that ground and form something like this.
Mm.
it is a base, like this will be 3 and this will be 5. So this will be 3, this is 5, and this will be height, right? H.
Yes.
Or they are saying Z.
Hmm.
Or it is this Z. This Z is given by this function. So Z equal to x by x minus 2 by minus 3. So this is the variation of height
Yes.
given by this Z.
Hmm.
Now the heap is shown in figure 1. This is the figure of heap. Then calculate volume of grains in the heap using 2 cross 2
God.
Gauss-Legendre rule, providing two values. First one, function value at any one of the Gauss point, then do second one, volume of grains. Just try, then I will explain what you are thinking. Just try.
Yes. Z is 5. Height.
Yeah, that is height. So this is our height. So like this will be our function, right? But we are calling fx. It will be
Yes.
now. Now we are having not we are having two variable function fx by.
Hmm.
Initially we had only fx.
Yes.
So fx by will be zx equal to x by x minus 2 x minus 3. And we want to calculate the volume. Okay, then one more thing. Okay, then you can solve. I just want to give you one hint. Then you can start. Here we will go. So for example, I want to calculate area for any of like by any function x. And I just want to calculate this much area.
Hmm. Hmm.
How we are doing? This is our x, this is our y. So we
Y.
are saying area A equal to
Hmm.
integration y dot
Hmm.
dx, right?
Hmm.
Correct na?
Yes.
So like y can be like it can be like function of we are saying function of x. So area equal to integration function of x dot dx.
Dx. Hmm.
Now I want to calculate volume. So for while calculating area, we are using one integration. Then if I want to calculate the volume, then we are going to use two integrations. So volume will be double integration function of x comma y dx dy. Understood? Na?
Yes.
So now you can think and you can try that problem. How we are going to solve.
F of xy, there in the question is xy and bracket x minus 2 y minus 3. F of
Yeah,
xy.
this is x by x minus 2 x minus 3. Only one student came. Around I think more than 1,000 registered for course. I think all are intelligent.
We have to solve like W1 X1 in this example.
No, we will have two variables, right? Because
Yes.
our function that z x comma y equal to
XY.
x by
X minus 2.
x minus 2 and then
Y minus 3.
y minus 3. So we will have w1 x1
Hmm.
and w2 x2 and y1, sorry, w1 for y1 and w2 for y2, right?
Hmm.
So we will say like we can say this one y1 w1 dash w1 w2 dash for this by. So our general formula will be like the I equal to integration I equal to 1 to m something, then j equal to 1 to m, then wi j something z x by this.
General form.
It will be general form. So just use 2 points. So the W1, W2, everyone will be like all of them will be one. So just use that for simple simplicity.
That W1 will be 1, W2 1, X1 1 by root 3 minus, and then the X2 plus 1 by root 3. This
Huh.
only.
Yeah. So the x1 and y1 will be same, and x2 and y2 will be same.
Yes. In that whole equation, initially we need to put minus 1 by root 3 in place of x.
Yes. But you have to change limit. Do you remember how we are going to change limit?
Yes, it is my.
We have to change limit now because this is not from -1 to 1. These are having some like first you have to fix that how we are going to that what will be limit of that x and y. But we have to decide that one.
Yes, it is left.
Hello, yes, can you hear me?
I can hear you. I thought you were asking someone else.
Yeah, yes, one person enjoyed.
Limit will be from 0 to 3, 0 to 2 in x and y direction.
Yeah, and x in y direction limit will be, yeah, obviously 0 to 0 to 3.
But we have from -1 to 1.
Last time I told you one formula A to B, something like that.
Yes.
You can use that one directly. So
Can you
no need
show?
to. Eh? You want to see?
Yes, that's fine.
Big one PDF. This is general formula.
Yes,
A to
got.
B, B minus A, something function of x. So that one you can use anywhere without changing limit of. Ankaj and yes, can you hear me? They don't want to speak. So okay, everyone, hello, I'm Ramko, I'm the T of this course. And if you have any problem, just you can unmute yourself and you can ask question. But first you have to go through all the video, then you will have more question. So I just request to all of you before coming to this class, just go through the all video, whatever shared by weekly. Then you will, if you have any problem, then you can ask to me. I will try to answer all the query.
In this equation, a and b are there, so we need to put 0 and 3 in first case, like limit is from 0 to 3 in x direction.
Or it will be used, should I start? Then it will be useful for you. Right.
Yes.
I will, I will solve this question. So it will take more time than this. My saving process need to. Okay, so I don't need to write. I already have ready-made answer. So, okay. So no, they are saying that we have to calculate the volume. So how we are going to start? As I told you, if we want to calculate volume, we have to use double integration. So this is our double integration.
Yes.
Limit will be 0 to 2 and 0 to 3. Why? Because we are having x value will be vary from 0 to
And 0 to 3 will be y.
it will be 0 to 2 and it will be 0 to 3, right? Fine. So this will be our that integration that we have to integrate.
Hmm.
Now if we are changing limit, for example, for example, we are changing 0 to 0 to 2, 2 minus 1 to 1. Or we can, if we don't want to change, we don't want to change, we will not change limit. This is just for like a simplification. So just we will forget about this one. We will directly come here. So B equal to volume will be like this. You are getting right, or
Yes, I am seeing it.
I will say like this. Volume. How, like they are changing limit. We can be, if we don't want, we will not change, because we are already having formula a to b like this. A to b fx dx
Yes.
equal to b minus a by 2, then function, but b plus a, right, or b minus a?
B minus A by 2.
B minus a by 2 into x1, right?
Yes. Plus B plus A by 2.
Plus b plus a by 2 into x2 into w1.
Into
So
W.
okay, so what we will do, we will not follow this one, and we will solve by using this our.
Here B plus that second term B minus A by 2 x1 plus B plus A by 2, it is x2. No, I
Yeah,
missed
this is
that.
x2, no?
Okay.
Or I will check one second.
No, it was not like that which you showed. Yes, see. It
Oh,
is
this is not
W1.
x2, yeah. Sorry. This is no, this is like simply b plus a by 2.
Hmm.
Sorry. Okay, na? Or I just will cut this one if possible. Okay. We can twist here. So, okay, now we are going to solve by using this our old method. So I will go to new page. Let's see, we will solve. We will solve. We are not able to solve. First, we will write formula. So a to b fx dx equal to b minus a by 2. Then function of b minus a by 2 x1 comma b plus a by 2, right?
It was plus in between.
Oh, here plus right there, right? Into x1, here will be x1
Yes, x1.
into w1
Yes.
plus function b minus a by 2 x2 plus, right? Here
Yes.
plus or minus, this plus or minus.
This is B minus A by 2. The
Okay,
rest is correct.
this is b minus. So now what we are going to do, we are having two variable in place of x1.
Yes.
So see, what will happen? B1 to B, we are going to add two times. See, this one they are going to see. This is for eta,
Theta.
like sorry, this is zeta, this is eta. So like 0 to 2, so it will be b minus a, right? B minus a, 0 to 2 by 2. Okay.
Yes.
Then it will be minus 1 to 1. Fine. Then again, this is 1.5. How it will 1 will come? 0 to 3. We are having 0 to 3 now. So 3
Yes.
minus 0 by 2, it will be 1.5.
Hmm.
Fine. It will be then again minus 1 to 1. Okay, this is fine. That's fine. Yes. So b equal to, I will write here b equal to 0 to 2, 0 to 3, z x comma y dy and dx. Okay, fine. So now we are having uh, this one for this is like y and this is x. If we like we are writing dx and dy, so it will be y, it will be x. Fine. Is someone getting or I'm just going?
I am understanding.
You are getting now, fine. What about other? Someone, yes, you can say yes, no, fine. So now our formula b minus a into x1. So b, we are having 2, b minus 0 by 2. This is also fine into zeta. So they are saying,
Um,
eh?
Someone has unmuted the mic but can't get the words.
Yes, Kothari, can you hear me? Yes. You can chat in, you can write in chat window so that I will get. Like these are question like if you go through the video now, you will get very fast. But without directly, because in UG we are not going through all these 2.3 point rule. Simply we are using that integration method. But these are numerical technique or some interpolation that we have to learn so that we can use in our FEM. That will be very useful in FEM, like further classes. Without these integration, we cannot solve any problem.
Also, in masters, we are not solving the problem. We are just mugging up that W1 X1 and then we are writing the code in
Yes.
console.
So, but okay, at least like before going to write any code, we need some like basic understanding, na?
Yes, yes.
Like some, for example, I wrote some code and I'm getting, for example, this is one structure. You are from structure division, then fine. So, like this is our one building,
Hmm.
two-story building, simple. Okay, I think. So, I'm putting some load at 20 Newton or 200 Newton, and you are
Hmm.
getting 3 meter displacement. Just for
Yes.
example.
Hmm.
But you wrote your code, well, then we can think code cannot give wrong answer. But by
Yes.
our simple understanding, basic understanding, we can this is totally wrong. It cannot happen.
Yes.
So again, we have to go and check how I wrote code. Maybe I missed some like that variable somewhere. I squared. I did some. Maybe I put plus in place of minus.
Hmm.
So for that we need some basic. Then we can write that not issue. If I'm all about that, we are going to write a big code.
Yes.
Okay, so what he is saying, let me read. Sir, 1 minute recap in this numerical will help me in getting this. So you want like recap, like whatever we did in last class? Then I will go through first. Just I will go. Just say me yes. Then I will start because it will be very deep. Like only one student listening and all of their know to the lecture itself. Yeah, sorry, 1 minute recap in this numerical will help me getting this. You want 10 minutes late. Then what should I do?
In this numerical only, not previous class.
Oh, he's saying this numerical only. Okay, so
Yes.
you can know just to go through this numerical and we have to solve. Okay, I will explain once more. Then you can start. Then you both of you will start. So we are having one that we are throwing some stone or some like on the floor and it going to like making heap. So this is they are saying some grains they are dumping on the floor and that grains are making this structure like heap. This structure and this height and this height going to follow this function zx, x by x minus 2, x minus 3. So now they are saying by using this rule, Gauss-Legendre rule, we have to find the volume of grains. Simple, very simple question. So now what we are going to do, we are going to, as we know that we have, if we want to find that area, what we are saying, one integration fx dx. If we want to find volume, integrate them, then we are using double integration f xy dx dy. So in similar way, now to find the volume of grains, we are going to use this volume. This is volume 0 to 2. Why? Because x, this is a outside x, limit x varying from 0 to 2. This is 0 to 2. 0 to 2. Then by varying 0 to 3. So this is 0 to 0 to 3. Okay, fine. Then function of xy, this is our function of xy. It is having x minus y, x by x minus 2, x by plus 3, something like this. Sorry, by minus 3. Hopefully you are getting then by minus 3. So now we are going to solve, how we are going to solve this integration. So by using that 2-point rule. Okay, so first what they did, first we have to change that limit. So we are having x by and x. So what first they did, they changed this limit of 0, 3 to this one, this 0 to 3, 0 to 3 dy in place, they replace by d eta. You are, Deepika, you are getting right?
Yes.
Then but they are keeping dx same. So just forget about this one, just concentrate on this term, this one only, this much. So b minus a, as we know that b minus a, so this is our b minus a. So 0, this is our a, this is our b. So b minus a. Okay. Then minus 1 to 1 z x comma y. So we are keeping x same, just we are changing limit of y. So we are not touching this x. So we are changing limit of y. So in place of y, what we have to do? We have to do b minus 2 f b plus b minus a by 2 x1 plus b plus a by 2. That formula we are going to use in place of y. So it will be like this: b minus a by 2, then eta here will be our x1. So this will be x1 plus b plus a by 2. Okay, na?
Yes.
Yes, sir.
That fine. Something. Well, just I will go through once again. Just so, but I'm doing. Oh, that will be okay. 1 minute. 1 minute. 1 minute. So just remember this formula. Okay. So what we are having, volume equal to 0 to 2, 0 to 3, function of x comma y dy dx. So first we have to convert this limit minus 1 to 1. So what we are doing, so just focus on this integration only. So I will write here I1 0 to 3 z x comma y dy. Okay. So it will be then I1 equal to b minus a. So b minus a, so 3, then I will write b minus a integration function of, so here will be x will be common because this we are not touching x. We are integration about of y. So it will be the x comma In place of y, we are going to write b minus a by 2, then by 1, because we are going through by, plus b plus a by 2 into w1. Similarly, plus function of, again we are not touching x b minus a by 2 plus b plus a by 2, then w1 w2, sorry, w2. So I hope you got what we are doing. So we are not touching x because we are integration about y only. So we are concentrating about y only. We are not touching this x. This will be constant. Now we are going to use value. We are going to putting the value of b and a. So how it will be like this? I1 equal to b. We are having 3 minus 0 by 2. Then function of x, it will be constant. Then 3 minus 0 by 2 by 1. Let's put right now by 1 plus 3 plus 2, 3 plus 0 by 2, then w2 plus function x b minus 3 minus 0 by 2 plus 3 plus 0 by 2, then w2. Okay, then we are going to solve this little bit simplification. So 3 by 2, it will be 1.5. Then function x comma, it will be 1.5 by 1, and it will also be 1.5 plus 1.5 w1. See w1 here. Plus function of x comma, it is 1.5 by 2 plus 1.5 into w2. Okay, so fine. Now I will cut this one. This one we will cut, copy, and I will paste here. Yes. Are you here, guys? Can you hear me?
Yes.
Yeah. So you got what I was trying to like explain. So now I will just keep it simple. I will remove all these things. So now what I was saying. So just we are keeping this one constant, and we are converting limit of that dy to dz, d eta. This limit only we converted. So like same we wrote like this one. See, we got same. This one. Like 1.5 eta. This one. 1.5 we are keeping here eta. So 1.5 eta plus 1.5 into w1. So in simple, how we can write I1 equal to 1.5 function of x comma 1.5, then simply we can put eta. We will not put even eta 1 or eta 2. It will be wi like this. Then again after converting this limit, then we will convert dx limit. So b minus 0 by 2 minus 1 to 1, b minus 0 by 2 eta plus, now we are not touching this one. And after it will look like this after doing all these operation. finally our volume will be volume integration will be like this one. So 1.5 I equal to 1 to 2. Why we are putting 1 to 2? Because we are doing 2-point rule. So 2.2 it will be 2. This one will be 2. 2.2. If we are going to use 3 points, it will be 3. So here they are saying 2 cross 2. It's mean that 2 in x direction, 2 in y direction also. So we are going to use 2-point rule. I don't think you are getting something. Yes? Sorry? Deepka also got muted. I don't know. He is not understanding. She is not getting anything.
Yes, yes, sir. I'm getting. The she is speaking, so
This is little bit like because we are using okay. So should I give one point rule? Then we will solve again this one. Okay, 1 point that just for like our practice. Because these type question going to ask in that exam. Now by after putting value, we will get this simple answer. 6 it will be answer.
sir, 1 minute. We need to see that screen.
Okay. But when you write, you will get just try to write this one. Then you will get what actually we are doing.
Yes, you can go.
You got now at how we are solving, right? You got
Yes,
idea.
yes.
What we are doing first, like we are keeping dx constant and we are converting limit dy to d eta
Hmm.
minus 1 to 1. So simple, just think about this one only. In
Hmm.
second step, we are converting this dx to g zeta.
Hmm.
And this is our final. And simply now as we know that this is our formula for cos rule. Then by adding all, then we are getting final answer. Okay, na?
Yes.
Fine. Then now we are going to move one other one problem. This is also simple, but little bit difficult, not that much simple. So we are having one simply supported beam loaded under certain loading, okay, and going downward. Okay, so we are having one simply supported beam. Okay, this is our simply supported beam. Okay, simply supported beam. Fine. Loaded under certain loading. Okay, bend down. Okay, ऐसे bend हो रहा है down. कुछ loading लगी इस पे. Oh sorry, in this. So we are putting some loading. Okay, going down such that the rotation of the left and right end. So that this is our left end. This is our right end. So the rotation at the left and right. Okay, so they are saying rotation theta 1 at left end is 10 degree and at right end theta 2 is 5 degree. They provided, okay, respectively. It is known that the shape of bend beam can be represented by using cubic polynomial. If length of the beam is 1 unit, okay, this is 1 unit, length is 1 unit, 1 meter, okay, anything 1 meter, 1 unit. It will be 1 unit only. 1 unit. We have to find the downward deflection. Location of maximum downward deflection and maximum downward deflection. Consider the left end of the beam as origin. This is our origin of our the coordinate. So just try and together and we will solve. Yes, can you try?
Yes.
So 1 minute, then I will come in 1 minute. Just try this question. So just will flow this one. Okay, so did you try? Are you getting something? A simply supported beam loaded under certain loading, okay, bends downward such that the rotation of left and right end, okay, this much minus 10, 5 respectively. It is known that the shape of the bent beam can be represented by cubic Hermitian polynomial. If length of the beam is 1 unit, then find downward deflection at the mid span. Okay, so at this point we have to find the deflection. Then location of maximum downward deflection. Okay, location we have to find. Then maximum downward deflection. Yeah. Oh, should I start?
Yes. Yes.
Okay, fine. So they are saying, okay, so we will go through one by one. They are saying we are having one simply supported beam. This is our simply supported beam, and having deflection 10 degree at left end. So this is our origin 0, 0, and this is having 10 degree deflection. This is having 5 degree deflection. Okay. Now they are saying we have to find something like displacement, some specific point, and that rotation as well. But they are saying the deflection curve can be, but they are saying that the this deflection shape of the beam can be given by using cubic Hermitian polynomial. So I think you guys went through this classes and sir discussed that cubic polynomial. Okay, so first we have to find the boundary condition. Oh, he left it. So now you are the only one you have to listen, Deepka.
Yes, yes.
So now we have to find that boundary condition. So okay, these are four boundary condition. This is our x equal to 0 and this is x equal to 1. Fine. So at x equal to 0, what we are having? X equal to 0. Deflection, like if we are saying deflection y, then y will be 0. And x equal to 0, that rotation y dash will be minus 10 degree. Fine. This is our boundary
Mm.
condition 1 at this is no, if we are saying node 1 and node 2. So this is at node 1.
Mm.
At x equal to 1, again deflection will be 0. And at x equal to 1, that rotation will be 5 degree. So these are our two boundary conditions that we are going to use to solve with our that problem. Okay. So these are the boundary conditions. At x equal to 0, y will be 0. Then theta is the y dash. So this is in 10 degree. If we are going to convert 10 degree to radian, so 10 degree divided by 180 into pi, it will be minus 10, it will be minus 0.1763. So this is same.
Mm.
At x equal to 1, y equal to 0, and theta equal to 5 degree. That is fine.
10 divided by 180 into pi.
Same. Similarly, we got this is radian
Yes.
and this is in degree. That's fine. Now we are defining one shape. This is phi x. Phi x equal to x minus x naught. And then how we are defining, because this is you went through that video.
Yes.
So you you went through all these this polynomial, right?
Yes,
Cubic.
not all, but I have.
So then how I will going to explain this? Like again, I have to start from zero.
It's
Anyway,
okay. You
like
can explain from here.
eh?
You can explain from here. We have learned in that graduation and PG level. It's okay.
Okay, then I'll let me find some content so that will be easy for me. So like for example, here we are having two nodes, right? Node 1, node 2. So we are going to define one function like phi x equal to x minus x naught. This is for this x naught. This will be x1 and x minus x1. This is our phi x.
Yes.
So this is called like some approximation function, we can say. So if we are putting value, we are having x1 equal to 0 and sorry, x not equal to 0 and x1 equal to 1. So we will keep, then we will get phi x equal to x is common as x. Then phi dash will be 2x minus 1. This is phi double x double 2. So this is the main thing that according to that that cubic polynomial, we are going to fit this this shape. We are saying this is a shape of the beam. And what is this? This is the like that Lagrangian interpolation. You know this one, L
Yes.
naught x, like x minus x1, x1 minus, like for example, we are having 3 point, like we are having this 3 point, 1, 2, 3. If I want to write in between these two, so x minus 1, 2, 3, 4. So if I'm writing at the, this is having 3. So if I'm writing at 3, so L naught 3 will be x minus x1, x minus x2, x minus x4 divided by, here we are going to write,
This we have learned like Lagrangian polynomial or something like that.
right na? Like this we are
Yes.
going to find. So these are the Lagrange polynomial, this L naught x. So x minus x1, then x naught minus x1. So we are having value, then we are going to we will get 1 minus x. This one.
Yes.
Similarly, so the L naught for this x node, and this L n1 will be for x1. So this is our x1. These are like some predefined formula how we are going to use. So if you go through that lecture, you will get why we are writing this one.
Yes.
So we already calculated phi double x. We are having phi double x. This is our phi double x, and phi dash x. We are having phi dash x. Then when we are putting value, we will get h1 and h2. This sorry h1 and h0.
Yes.
To put in this formula, then we are going to put in this one. And we will get this is our final shape. That this is the shape of real that our sorry not net. This is f dash.
Calculator is not allowed.
Calculator allow na, we can use calculator.
Mm.
So this will be our shape of the beam.
Yes.
Beam shape. Or we can say by like so this is following cubic, right? That as they mentioned, okay, that is fine. And then they are saying find the deflection at x equal to 0 point something. Like they are saying mid of the span. So it means that they are saying x equal to 0. It will be x equal to 0.5.
Yes.
It will be x equal to 0.5, 1 by 2. Because length we are having 1 unit. So when we are putting x equal to 0.5, when we are putting x equal to 0.5 in this equation, we will get the downward deflection at midpoint. This will be our answer, right? Then they are saying deflection at x equal to 0. So this will be our at x equal to 0. No, they are saying maximum deflection. Then how we will calculate maximum deflection? We are going to differentiate this one and we are going to put that 0. Like if I want to calculate y equal to fx, so what we will do? We will calculate y dash equal to df by dx equal to 0. Then we will get two value x1 and x2. Right? To calculate the maximum, we are taking differences, na? So we will get x1 and x2. So they are saying what is the location of that maximum deflection. So if you will keep that x1 and x2 in this equation, you will get that maximum value. So this will be our answer. That look, they are saying x equal to this will be our maximum. That at this point deflection will be maximum. Right now?
Yes.
Hopefully you are getting. Then maximum deflection value. So we are going to put this one in our this function. This function. So this is minus 0.88 into x power q. So this will be our x power q. Then plus then x square. So we are putting in place of x. This one. This is our to get the maximum deflection. Right now?
Yes.
So x is the point. At this point, the deflection will be maximum. Then what will be maximum value? Then we have to put that x in the function. Then we will get the maximum value. So Just you can imagine these type of question they are going to ask in your exam and in your quiz. So this simple basic question, but it will take some time because if we are doing it will not be easy to solve within that given time limit. These are some previous questions that I'm just trying to solve with you so that you will get some idea what type of question they are going to ask. And I think if you gone through some that last week assignment, you will find these type of question only. Right now?
Yes. Yes.
Okay, then we are going to start new question, some simple question we will take. So now this question you have to solve. For x equal to 10x, find out the derivative at x equal to 1.5 using Richardson extrapolation with x equal to 0.02, 0.04, 0.08. In the answer below, provide the value of the, this is one of the that your assignment question. Provide the value of f dash x for different value of h in sequence and find final value of f dash x. Oh, okay. Try. Okay, I will tell you some formula, then you will get. So we are having function f(x) equal to 10x. Let me write, we will write all the. Then we want to find derivative at x equal to x equal to 1.5, and they are giving some constant h equal to 0.02, 0.04, 0.08. These are the some constant. So according to that Richardson extrapolation, phi x, x comma h, there are some formula. Phi x comma h will be f x plus h minus f x minus h divided by 2h. Okay. Now then what will be our x f dash x? F dash will be
X square.
f dash x comma h will be phi x comma h by 2. These are some predefined formula that we don't have to think how I am getting. They are having some derivation, but we don't want to go that much depth. X comma h by 2 minus 5 x comma h plus o h power 4. Do you know what is this o h power 4? Huh?
No.
No, I think you went through in UG courses like we are having uh, like what we call like the inner power, something like this. Do you remember in one course we were studying?
We haven't came across zero H power.
Okay, fine. So now we are going to we are going to calculate this one. So first, what we have to do, we have to find f dash x h. So we are having x equal to 1.5, and we are having three value of h equal to 0.02, h equal to 0.04, h equal to 0.08. Fine. So now f dash, okay, now one of you will find. See, we are having fx, this is our fx, okay. We are having phi, this is our phi, okay. This is okay. So this is our phi. How you are going to calculate Okay, one of you can you tell me what is the f x comma h at h equal to 0.02, given that x equal to 1.5. Okay, just tell me what will be value of f dash x comma h at h equal to 0.02. Yes, you have to find this value at this h equal to 0.02 and x equal to 1.15. So, any of trying or just I will start solving? Deepka? Okay, then I will solve. Fine. Okay. So I will start how we are going to calculate f dash s comma x comma h. So we know that we have phi x comma h. This is our formula. So first we will find at I will write here at h equal to 0,02 and x equal to 1.5. We have fx equal to 10x. So then what will be fx plus h? Then x plus h will be 10x plus h. Fine. Then 10x plus h. Okay, so then f again x plus h equal to we have okay. Let me put that value. I will put those value here. So f x we are having 1.5, h we are having 0.02 equal to 10 1.5 plus 0.0. So it will be 10 1.52. It will be 1.52. So 10 1.5, this is radian. So we have to calculate 10. Sorry. 1.5 1.52 10. It will be minus 1 point. Yeah, it can be minus Okay, so we are getting minus one point. This is minus 1.09. So our fx plus h equal to, so this will be our minus 1.09. Fine. Okay, fine. So then what is the value of phi x comma h equal to? This is, we are having fx plus h. So fx plus h minus that f x minus h by 2h. So what will be phi 1.5 comma 0.02 equal to, we are having minus 1.09, minus value, it will be plus 1 point. Oh, this is coming 0. No, this is f. Oh, sorry. So then now we have to find, before going to find phi, we have to find f x minus h. So what will be value? F x minus h will be 10 x minus h. So f x we are having 1.5, h we are having 0.02. It will be 10, 1.5 minus 0.02. It will be 1.48. It will be again this is 0.017. Okay, so we got fx plus h and fx minus h. Now we can put in this formula this, and then we can calculate the phi. So our phi will be phi x comma h equal to fx comma h equal to fx plus h minus 0.9 minus 0.017 divided by 2h to 0.02. So it will be minus 1.09 minus 1.09 minus 0.7 divided by 0.04. It will be minus 27 minus 27.067. Hopefully you guys getting okay. So this will be minus k 27.67. But now we have to calculate the f dash xh. So this is our f dash xh. Now what we have to do, we want to calculate phi x comma h. So phi x comma h by 2 we want to calculate. So it will be, we are having phi x, so it will be f x plus h by 2 minus f x minus h by 2 divided by 2h by 2. It will be 1, so it will become f x plus h by 2 minus f x minus h by 2 x. Oh, someone listening or I'm just writing? Then while putting this value in this one, you will get, yes sir. So now I will explain here. So this is our fx equal to 10x. This is our fx. Then this will be our phi x. This is our phi x. Then we want to find f dash xh. So this is our f dash xh. So this will be at, now we are going to calculate at x equal to 1.5 and first h equal to 0.2, second h equal to 0.04, then third one h equal to 0.08. So you will get f dash at 0.02, f dash at 0.04, f dash at 0.08. So these will be our three value. Now by using this Lagrangian polynomial, we are going to fit this, we are going to extrapolating this data for x equal to 0. Okay, so this is our h and this is our f dash x comma h. So h equal to 0, we got 199.4849. This will be for 0.04, this will be 0.08. Now, as I told you, if we are having 2.1, 0.2, so this is having x1, this is having x2, or we will say x node. It will be good if we are call x node. So this is x1. And if I want to write L node x, so L node x will be x minus x1 divided by x node minus x1. For other case, for example, I'm having 4 node. So x node, x1, x2, x3, x4. So I'm having 4 node and I want to write for this x2. So L2x equal to x minus x node, x minus x1, x minus, there will not be x minus 2, it will be x minus x3 and x minus x4. Divide by, here we are going to write x2 minus x node, x2 minus x1, x2 minus x3 and x2 minus x4. So this will be our Lagrangian extrapolation. So like for example, if L node, this will be our L node. So H minus, we are having 3. Here we are having 3 node. So this is 1, 2, 3. So this is H node, this is H1, this is H2. So for L node, it will be H minus H1, H minus H2. Then H node minus H1, H node minus H2. So then I will write here how they got. So L node H equal to H minus H1, H minus H2 divided by H node minus H1, then H node minus H2. Now, so this is our H node, this is our H1, this is our H2. So H node, H1, H2. So now we are going to put in this formula. So this will be our L node H. Similarly for L1H, L2H. Oh, this should be H node. This should not be X here. This is H. Yeah, it should be H. Okay. Now by summing all these, so we will get LH, L node Y1, L1, y1 L2 by 2. So at x equal to 1.5, this will be our L node H. And what we have to calculate? Okay, that one we have to find. Hopefully you are getting here. But note that derivative very sensitive to the choice of H at the evolution is the being done very close to singularity, hence the answer differ significantly from the answer. This is some note. Okay. Then then coming to next question. Or it will be next question. Okay, this is the next question. This will be next question. Consider a cantilever beam fixed at left support. Okay, this is our cantilever beam and loaded at the free end as shown in figure. Okay, this is free end, this is loaded. Fine. Which one of the following weighting function is suitable if the beam is required to solve for vertical deflection by strong form of method of weighted residual? Consider these condition as arbitrary constant. So like we are saying C0, C1, these are the arbitrary conditions. So we have to we have to find that which one going to that fit that equation of the deflection. Okay, no? This is weighting function. Okay, weighting function. So what will be boundary condition for that cantilever beam? If I am saying x equal to 0 and this is x equal to L. So at x equal to 0, our displacement will be 0 and at x equal to 0, why the deflection, sorry, that rotation will have some value, it will not be 0. If we are saying fixed, it will be something 0 like. Shape will be like this. So how we are going to fit, how we are going to calculate that which one will be fit for this one? Then we will go to answer. What is the Dirichlet boundary condition that we have to remember? Someone listening or I'm just speaking? Let me find to speak someone. Pradhan and 2 and 3 are here. Yes, and yes, can you hear me? Yes, fine. So it's very difficult to like because if you finish that video now you will get very fast these all these question. But I'm just trying to something like so that you will get some idea. These are like little bit difficult question, but if you will go through that all the video, then easily you will get. Then I will teach something like these question. I will take in hold. Um, then I will open one FEM1. This one I will teach you what is the weighted residual method. Then it will be easy for you to as well. Modeling, 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 modeling. What should I teach you guys? Can you just let me know? Because these are all are the big two classes, and you have to finish. Then you can understand what I'm telling to you. What week? I will tell you one thing. What is week and what is. Yeah, right. Because without going through video, and it will be very difficult for me and for you as well, because I will go through something and I just will finish my 2 hour and it will go. But that's not a good way to waste our time. Okay, then I will give you one question, then just try give me that answer. So you have to solve that one. I equal to integration 0 to 5 sine square, not sine, -1 to 1 to keep it simple. I equal to -1 to 1 e minus x square into x cube dx. So you have to find by using 2-point Gauss Legendre rule. Just find by using 2-point rule. Then how we are going to solve? We know that if I want to find any indication, -1 to 1, -1 to 1 fx dx equal to w1 fx1 plus w2 fx2. Why we are using this method? Because these integration we cannot find by using simple our whatever we studied in our that UG or in our school. We cannot use these method here. So we are going to use some approximate method. That answer will not be exact, but it will be nearby. For example, if I will say 1.98, 1.02, so we can say both are nearly 1. Oh, sorry, not. Then 2.02. So we can say both are nearly 2. So these are the approximation. So by using this method, you will find that the that approx value of integration, not exact. Sometimes it can be like whatever we are finding. Sometimes it can be exact value, but normally this is not going to happen. So now by using 2-point rule, what we are going to, so we know that W1 equal to 1, W2 equal to 1 as well. Then x1 equal to -1 by root 3 and x2 equal to 1 by root 3. So now we are going to put these 4 value in this equation, and we are going to see what the value of this integration. Okay, now we have to put this value. So I equal to minus 1 to 1, that's fine. W1 we are having 1, so W1. fx1 means e minus 1 by root 3 square into minus 1 by root 3 cube. That's fine. Plus W2, it will be 1 again. Then e minus 1 by root 3. So it will be plus, okay, so it will be minus here, okay. 1 by root 3 square into 1 by root 3 square cube. So this will be e power 1 by 3 minus 1 by 3 root 3. Okay, na? 3 root 3 plus e minus 1 by 3 into 3 by root 3. So if I will take common minus 1 by 3, it will be minus 1 by 3 root 3 plus 1 by 3 root 3. So it will be 0. Oh, that's good. So our integration will be 0. Now just try to solve by using any MATLAB or any other code. You will get the value 0. So this will be exact. Or this is that odd function anyway you are going to get that 0 only. If I will say I equal to minus 1 to 1 e minus x square and x square dx. So this is even function. This is the even function because if I am keeping f minus x, if I am replacing minus x, then if we are getting fx, this is the even function, and for f minus x equal to minus fx, this is the odd function. Okay. So these are some 2-point rule, and for example, if I want to solve by using 3-point rule, so how we are going to solve? So same problem like I equal to minus 1 to 1 e minus 1 by root, sorry, e minus x square into x cube dx. So we want to W1, W2, W3, x1, x2, x3. We know all these 6 value, then integration will be I equal to W1, fx1, W2, x2, W3, fx3. And now by putting these values, we can get what will be W1, W2. So W1, W2, we remembered here. So this is the for 3-point rule. These will be value. So this will be W1 will be 5 by 9. X1 will be minus 3 by 5 under root. W2 will be 8 by 9. X2 will be 0. W3 will be 5 by 9. X3 will be plus 3 by 5. So now by using this 3-point rule, you can solve this question. And I don't think you are going to get same value as 0. Okay. So I hopefully like next week, please finish your previous week video so that you will get the some idea, because slowly, if you are keeping for that tomorrow will not come. And after some time, this much will be like accumulated and you will not be able to finish. Okay. And these are very good. These whatever sir going to teach you, these are very good concept, and like no one can no one can teach like him. So I request all of you, please finish your video. And if you have any query, then next class, like still you are having 6-7 days. So every week you are getting, I think, 4 to 5 video. 4 to 5 video you can finish within 1 hour video. You will, if you will take during lunch or during breakfast or during dinner, if you are watching, then you can finish easily. And regarding PDF, if you go through website, you will get all the PDF, so you can download those PDF. So no need to write all these things. Just download and go through and solve your assignment questions so that you will get some idea what type question they are going to ask in your exam. Because if you are not doing any practice, that will be very difficult for you to write that exam. Question will be little bit difficult and little bit tricky as well. Like, see, this question be seen. This is very big question, like this much 3-4 line, but answer only 2 line. And just before that question also, which one? This one also. So this very important to do more and more practice and take. I hope that these are right now they are start teaching basic, but next week, I think this week itself, like third week, he going to start that weighted residual method. Then 1D, then 2D and 3D. It will go like this. Then at the last, CSD, computational dynamics. So someone say yes or someone say no. Just write something on chat window so that I will get. I'm not talking with that computer. Someone sitting. Yes, someone sitting so that it will be useful. Because before going video, I wrote so many things, but it not be easy to understand. I went through 3-4 times, then I got something that FEM we are going to study, because FEM little bit difficult subject. So I will tell you one question, like how we are going to use that FEM in real problem. For example, uh, this is one of the structure. Mm, so this is having 2 story, 3 story. Okay. This is our one structure, and okay. So if I'm we can give some like wind load. Some wind load is coming here like this. So we are having these are so slowly we will get. So we are having different type of element, like this is beam element, cell element, then solid element. For example, if I'm saying, and one element, this is one element, and it is having, they are having node, so this is called node 1, this is called node 2, and at node 1 they are having 3 degree of freedom. So 1, 2, and 1 like x1 by 1 and theta 1. At node 2, x2 by 2, then this is theta 2. So this is element 1, element 1. So if I will say what will be the stiffness matrix for this element, so it is having it is having two node 1, node 2, and each node having 3 degree of freedom. 3 degree of freedom. So number of node equal to 2, and each node having 3 degree of freedom. So our stiffness matrix will be the size of stiffness matrix will be size of K will be 2 into 3. It will be 6. So our K stiffness matrix will be like this. K element equal to 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So like it will be 6 by 6 like this. This is our stiffness matrix. Then similarly we will get mass matrix, similarly damping matrix, and similarly force matrix. So if I am putting some load, say F, and I want to find displacement at this, or say this point, by this this is dynamic load. If I will say this is dynamic load. This is dynamic load. So as we know that we will get one dynamic equation motion F x double dot plus C x dot plus Kx equal to F of t. So now by using Newmark beta method, something I'm just telling you, Newmark beta method, other technique, we can get that response value of x by like this will be our K matrix, this will be our damping, mass, load. Then we have to solve by using our writing MATLAB code, some Python code, then we can get the response of this node. Something like this. I think that's enough for today. And if you have any query, you can ask to me. I will be happy to answer. Okay, thank you. So I think we can bind up for today. We will meet in tomorrow, that next week. Hopefully you guys will complete your pending video, so it will be easy for me and for you as well to get the concept. Yeah, thank you. Guys can leave now.